Okay. In continuation with the previous video, I would like to explain one problem on Taylor's expansion. Suppose if you have been given a question like expand f of x comma y is equal to e power x sine y. Question is like in powers of x and y up to third degree is the question, or up to third degree is the question. I think it's clear. I think you are clear in powers of x and y. Which formula do I have powers of x and y? The second formula has powers of x and y. First formula has powers of x minus a and y minus b. Okay, when you are asked to find like that, you will be doing using the first formula. Anyways, I will discuss one problem on the first formula as well. Okay, coming to this one, how do I start? What do I do? Okay. Please see here, in case if this is not given to be f of x comma y, you will assume that it is f of x comma y and start with. It'll be f or phi or xi or anything is fine. Okay, you should g, h, anything, g of x comma y, h of x comma y, anything is fine. Okay, what do I need for the Taylor's expansion? I'll be needing the derivatives, right? Fx I'll be needing. See, fx is nothing but partial derivatives, guys. Dou f by dou x. I need to find out what's the x term in f of x. The x term is e power x. So e power x derivative is e power x only. Very easy, right? Yes. Now, what would be fy? Fy would be dou f by dou y. What's the y term? That is sine y, right? So e power x is a constant. Sine y derivative would be cos y, right? I'm done with my first order derivatives here. I hope you are understanding. Okay. When I'm doing partial differentiation, there are a set of derivatives. The first order, the second order. Ma'am, till what order we will take? Till whatever is necessary for the problem. Depending on the problem, we will be considering the number of derivatives, not any number and every number. Okay. Yes. Now coming to the second order derivatives, fxx would be nothing but second time derivative of dou f by dou x, which would be dou square f by dou x square. Again, my x term is e power x. E power x, how many ever times I differentiate, it would be e power x only. Sine y is a constant with respect to x, so it is like that, right? Now, the fx1 I have already differentiated, that I am doing it with respect to y again. It's nothing but, see here, dou f by dou y dou x, or first with respect to x and then with respect to y. Okay. Either ways also I get the same answer, right? E power x is a constant because I'm differentiating with respect to y, right? So sine y derivative would be cos y, guys. This is same as fyx as well. Please do check. Okay. For confirmation. Next thing is fyy, I'll be differentiating again with respect to y. That would be nothing but dou square f by dou y square. In the formula also I would have written in this format, but that looks very huge, because of which I am writing it normally using the suffix notation. I hope you understand. Now, the y term would be cos y. Differentiation of cos y, you all know, would be minus sine y. Fine? Yes. Now, next thing, third derivative he has asked now. So I'll be substituting accordingly. I mean, I'll be finding out accordingly. What are the terms that I need? fxx, fxxy, fy triple y, okay? And then fxyy, okay? Yes. Now here, I can add on one more term here, one more thing here. I'm finding out in terms of x and y. That means about, I'll just write in a different color so that you understand. In powers of, I'll write it here, in powers of x and y implies about the point 0 comma 0, about 0 comma 0, or in other words, this implies the Maclaurin's series expansion. Okay, it's not the Taylor series exactly, the Maclaurin's expansion. So I'll be substituting the values 0 comma 0. Okay, fx at 0 comma 0 would be x is 0, y is 0. E power 0 is 1, sine 0 is 0. You know that, right? Yes. Fy at 0 comma 0 would be, shall I do it with a different color so that you are clear that what exactly I am doing? Yes. Yeah. Coming to this one, e power 0 is 1. Cos 0 is also 1. So fy 0 0 would be 1. Okay. Similarly here, fxx f double x at 0, comma 0. Again, put in the place of x 0, in the place of y 0. Wherever sign is there, I'll be getting 0 only, guys, because sign 0 is 0. fxy at 0, comma 0 would be what? E power 0. Wherever cos is there, I'll be getting 1. Okay, right. Then fyy at 0, comma 0 would be what? Again, I have a sine term, so this also would be 0. Sine 0 is 0, right? F triple x. Please look at f triple x. It's nothing but dou cube, I'm sorry. This is dou cube f by dou x cube. It is 3 times derivative of f with respect to x only. Successively with respect to x. No change in it. E power x sine y is what I will have. Next, fxxy. Already with x I have done twice here. This is the one, guys. Now I'll be doing that with respect to y. So the resultant fxx is e power x sine y. This with respect to y would give me e power x sine y derivative is cos y. Clear? Right. Next what I have is fxyy. Okay. Already I have done this one with respect to y, right? Not after substituting the point 0, comma 0, guys. If I differentiate the term after substituting the point, it would be a constant and derivative of a constant would be 0, right? So I'll be considering before substituting a constant. And clearly I can see, of course, when I put 0, sign would anyways give me if sign is there, it would anyway give me 0 only, but then I have to do it because see 2 times derivative with respect to y and then with respect to x. So e power x derivative is e power x, sine y derivative would be with respect to x would be sine y only. Sine y is a constant, right? Yes. Last term, before going to the last term, let me evaluate f triple x at 0, comma 0. When sign is there, the term goes to 0 because sine 0 is 0. fxxy at 0, comma 0. Since cos is there, I'll be getting it to be 1. Yeah. fxyy at 0, comma 0. Sign is there. So again, this term would be 0, whether with a negative sign or a positive sign. Finally, I'm supposed to be doing f triple y. I've already done f with respect to y twice. I'll be doing this again with respect to, I'll just shift this. I'll be doing again with respect to y. Now I have sine y here. It becomes cos y. The sign doesn't change. Okay. So minus e power x, sine y would be cos y. And then this term value at 0, comma 0 would be what? F triple y means derivative of f with respect to y thrice would give me what? Would give me what? Minus 1. Okay. Now, all these things I'll be substituting in the formula. For the exam, you need to write the formula, rewrite the formula. I mean, write the formula because this is not your notes. Okay. So, I'll be writing. Please see here. Let me write with a different pen so that, yeah. Taylor's expansion. Taylor's expansion. E can be small, guys. T is the name of a mathematician, so I'll be putting it capital. Taylor's expansion of f of x comma y about the point 0 comma 0. About the point 0 comma 0. What will I get? See here. F of x comma y. This is equal to, make it a point to rewrite it once or twice so that you don't forget. Okay. 1 by 1 factorial x into fx at 0 comma 0 plus fy. I'm sorry. Y into fy. Y into fy at 0 comma 0 plus 1 by 2 factorial x squared fxx at 0 comma 0 plus 2xy fxy at 0 comma 0 plus y squared fyy at 0 comma 0. Third term is also needed. It's been asked. So I'll put a plus here. That's the right way to write. 1 by 3 factorial x cube f triple x at 0 comma 0 plus 3x squared y f x x y at 0 comma 0. I hope you understand the rhythm. X squared is there, so f double derivative with respect to x is there. xy squared is there, so one time derivative with respect to x, two times derivative with respect to y. Okay, by the way, this is a theorem, but then the easiest way to remember is what I'm trying to focus on. Okay, y cube f triple y at 0, comma 0. Okay, let me put plus dot dot. He has asked us only till the third term. Okay, up to third degree terms. So we are doing this. Okay, yes. Now, what are all the values that I'll be substituting? Whatever values I have got at the point 0, comma 0, I'll be substituting. By the way, guys, this is the easiest. Maclaurin series is the easiest. If you think, if you get this in the exam, you're done. Your job is very, very easy. Okay. This is the easiest question that you can get in the exam. Okay. Yes. X squared into f double x is 0 that I've got because there was a sign plus 2x into y into fxy is 1 plus y squared into f double y is also 0. 2 times derivative of y. Sine gives me cos, cos gives me sine again. Okay, because of which that also is 0. 1 by 3 factorial x cube. Again, f triple x is also 0 because I have sine. Then 3x squared into y into f double xy is 1 because I have differentiated with respect to y. Sine has become cos. 3xy squared, okay, into the other one is 0. And then finally, y cube into minus 1. I can clearly see here it's minus 1. Okay. Yes. Plus and so on. Just remove off all the zeros and you get the series. That's it. It's very easy. Okay. So I'll use a different pen to cancel out all the zero terms. Okay. F at 0, comma 0 is 0. This also is 0. This also is 0. This also is 0. This is 0. This is 0. So finally, I am left with this one, this one, this one, and this one. Okay. I'll write the series, right? Okay. It would be what? Y plus 1 by 2 factorial. I am taking it inside or I will write it like this. 2xy by 2 factorial. Tell me the final output. Okay, guys? Yes. 3x squared y by 3 factorial. Okay, minus y cube by 3 factorial. See, it doesn't stop here. It's an infinite series. Taylor's expansion is an infinite series. Okay, I'm not going into the detailed version of it. Why? Because this is an exam orientation, right? Okay, 2 by 2 factorial would be 1. Okay, and then this would be what? 3 by 3 factorial would be what? X square y by 2 minus y cube by 6 is what I will have plus dot dot. This is my Taylor's expansion. Is it easy? Yes, it would definitely be easy. Okay, for you. Yes. I'll do one more problem on powers of x minus a and y minus b. Okay. Yes, in the next video.